All right, beginning our conic sections unit. Today we're going to be talking about Chapter 10, Section 2, the parabola. So a parabola is a collection of all the points P in the plane that are the same distance from a fixed point F. So take a peek at F here on your, so we call as, so this point is the same distance from F as it is from a fixed line D. The point F is called the focus. The line D is called its directrix. As a result, a parabola is the set of points P for which the distance between F and P is equal to the distance between P and D. And a couple things to note is that the distance from the vertex to the focus is the same as the distance from the vertex to the directrix, which is the distance from the focus to the directrix is 2 times this A value. All right, so we're going to take a peek at parabolas with their vertex centered at the origin. Remembering that the distance from the point FP is equal to the distance from P to D, our equation, so here's how I remember the equation. If you have your y squared, so whatever term is not squared, you open around that axis. It's like trying to give the x-axis a hug. So this one is y squared equals 4ax. And remember, a is the distance from the vertex to the focus. So y squared equals 4 times a times x. So the equation of a parabola with a vertex at 0, 0, and a focus at a comma 0, as long as a is greater than 0. The equation of the parabola, the focus is at a comma 0, the directrix is equal to x equals negative a, is y squared equals 4ax. So let's put some numbers on top of that. Find an equation of a parabola with a vertex at 0, 0 and a focus at 3, 0 and graph the equation. So remembering that y squared equals 4ax, we know that a is equal to 3 because it is the coordinate of our x value for our focus. To graph the parabola, we find the 2 points that determine the latus rectum by letting x equals 3. So y squared equals 12x. And then we know when x is equal to 3, that y has to equal plus or minus 6. I think I need to see the picture of that. So we know that the vertex is at 0, 0. The focus, and remember, our parabola always curves and wants to hug our focus. That's how I think of it. We want to hug our focus, and we want to shun our directrix. So our focus is at 3, 0. Our directrix is at x equals negative 3. We get 2 points, which is at 3, 6, and 3, negative 6. So just for clarification's sake, the line that joins a comma 2a and a comma negative 2a is called the lattice rectum. It goes, it's a line that goes from your parabola, hits your focus, and hits the other side of your parabola. These points help in graphing the parabola because they determine the opening, so how wide your parabola is. Alright, so we're going to analyze the equation of a parabola. We got y squared equals 8x. We're going to find the directrix. We're going to find the focus. We're probably even going to graph it. So, when we compare y squared equals 8x to y squared equals 4a times x, we see that 4a is equal to 8. So a has to equal 2. This means, with our vertex at 0, 0, that the focus has to be at a comma 2, which is a comma 0, which is 2 comma 0. The directrix has to be at x equals negative 2. And then now we're going to find the lattice rectum. So it is at, if x is equal to 2, y squared is equal to 16. And so y is equal to plus or minus 4. So the points 2, negative 4, and 2, 4 are the lattice rectum. That is how we analyze this graph. And it looks like this. So we draw the graph. We throw down the focus. We throw down the directrix. We make sure our vertex is at the right point, and then we open. Alright, so the equation of a parabola with its vertex at 0, 0 and a focus at the axis is going to give you a focus either at a comma 0 or at negative a comma 0. If it opens right, it's positive a. If it opens left, it's negative a. The directrix is going to be at x equals negative a for a right opening parabola, and it's going to be at x equals a for a parabola that opens left. The equation for a parabola that opens right is y squared equals 4ax, and the equation that opens left is y squared equals negative 4ax. When I have a parabola that opens up or down, this is the classic parabola that we've usually fussed with. Once again, both vertices are at 0, 0. When I open up, my focus is at 0, comma a, and my directrix is at y equals negative a. The equation that represents a opening up parabola is x squared equals 4ay. And then for one that opens down, my focus is at a negative a, or 0, comma negative a. My directrix is at y equals a, and the equation of the line is x squared equals negative 4ay. Alright, so we're going to take a peek at this guy right here. X squared equals negative 12y. So the first thing we're going to do is we're going to compare it to the original equation. X squared equals negative 4ay. So we can see that a is equal to 3. The vertex is at 0, 0, and our focus is at 0, negative 3. That negative sign in front here means that we are opening down. The directrix is a line y equals 3 because it's the opposite of a. The parabola opens down and its axis of symmetry is the y-axis. To obtain the lattice rectum, we let y equal negative 3 here. And we get x squared equals 36. So x is equal to plus or minus 6. So the points -6, -3, and 6, -3 are on our parabola, and they are 2 points on our latus rectum. And it looks like this guy. So our focus is at 0, -3, vertex at 0, 0, directrix is at y = 3, and we go through the points -6, -3, and 6, -3. All right, so let's take a look at finding the equation of a parabola. We're given that our focus is at 0, 4, and that the directrix is a line y = -4. Graph the equation. I always like to draw the picture first. I know because I am a visual learner, so the first thing I would do in this scenario is I would graph this point here, 0, 4, and I would graph the line y = -4. Then you can see that this is a parabola that opens up, and start putting it together. So we know that it's a parabola that opens up, so we're going to pull the equation x squared = 4ay for an opening up parabola. We know that if x squared = 4ay, that our a value is 4. So we put that in here. So it's x squared = 16y. The points 8, 4 and -8, 4 are the latus rectum, because when we put in our a value of 4 for y, we get out 64, and the square root of 64 is ±8. That's how that happens. So if we look at the picture, which is what I would draw first, we see that the vertex is at 0, 0, and our focus is at 0, 4. Our directrix is at y = -4, and then our latus rectum is at -8, 4, and 8, 4. Nice parabola here. Okay, let's do that again. The equation of a parabola with a vertex at 0, 0. The axis of symmetry is the x-axis. So it opens, it's either going to open right or left. Its graph contains the point -1/2, 2. Its focus, find its focus in directrix and graph the equation. So we are going to, the first thing I'm going to do is draw a little picture of this point so I can see where it's located at. Because of the location of this point, -1/2, 2, and the fact that it's symmetrical with respect to the x-axis, we know that it's a left-facing parabola. So we use the left-facing parabola equation, y squared = -4ax. We're going to go ahead and plug in -1/2 for x and 2 for y so we can solve for a. Half of 4 is 2, and then negative and negative is a positive, so this would be 4 = 2a. And then you divide both sides by 2, so 4 divided by 2 is 2, so a is equal to 2. We can go ahead and put that in our equation. So our equation is y squared = -8x. Now we have to find the focus and the directrix. The focus is at -2, 0, because we can see that our a is 2, and since we open to the left, it's -2, 0. The directrix is at x = 2. It's opposite of what's in here. When we let x = -2, we get y squared = 16, so y is ±4. So the latus rectum is at -2, 4, and -2, 4. All right, so now we're going to move our vertex from the origin to anywhere on the xy axis or xy plane. So the way that it changes our equations is that instead of a vertex of 0, 0, we're going to have a vertex of hk. So for a right opening parabola, we're going to have h plus a as comma k as our focus. Our directrix is going to be x equals h minus a. The equation is, so since we now have x and y on different sides of the equation, we're always going to subtract our vertex. So it's going to be y minus k squared equals 4a x minus h. So what you're going to go opposite of whatever your vertex is inside of your equation. For a left opening parabola, it's going to be h minus a comma k, x equals h plus a, and we are still subtracting our h and k, except our 4 is now negative. So for conic sections, I always find that the picture really focuses and centers my thinking on how to come up with the equation. So my number one suggestion when you start a problem is to go ahead and graph the information they give you, step number one. And then it'll help make clear which kind of parabola you're working with. So open up and open down. Instead of the y being squared, our x value is now being squared. H always sticks with the x, and k always sticks with the y. So our when we're opening up, our focus instead of, the h value is a part of the focus, and then it's k plus a for an opening up parabola. For an opening down parabola, so that looks like this. So the focus is at h comma k plus a, and the directrix is at y equals k minus a. For an opening down, the focus is at h comma k minus a, and the directrix is the opposite, y equals k plus a. Your axis of symmetry is x equals h for both, and your little equations look like this. All right, so if we find an equation of a parabola with a vertex at -2, 3 and a focus at 0, 3, we get to graph the equation. So the first thing I'm going to do is draw a picture of this. So the point -2, 3, when we graph that, is on the left-hand side, and the focus 0, 3 is on to the right of that, and we can see that because of the vertex and the focus, our parabola always wants to hug the focus. So this guy opens to the right. So we pull our right opening parabola equation. We know that h and k is -2 and 3, and a is 2, because the distance between the vertex and the focus is 2 units. So our equation is y minus k, so y minus 3, squared equals 4 times a, which is 4 times 2, times the quantity x minus h, h is -2. And then we simplify that to y minus 3 squared equals 8x plus 2. We're going to go ahead and graph that. To graph it, we find the latus rectum, and our focus is at 0, so we go ahead and let x equal 0. So when we do that, we get y minus 3 squared equals 16. And we take the square root of both sides. We get y minus 3 is plus or minus 4. We add 3 to that. If I am positive 4 and I add 3, I'm at 7. If I'm at negative 4 and I add 3, I'm at negative 1. So the points 0, negative 1, and 0, 7 are at the lattice rectum. And the line x equals negative 4 because our directrix is at h plus a. So h is negative 2. H minus a. Minus 2 is negative 4. We put all those things on our graph. Directrix is at x equals negative 4. The lattice rectum is at 0, negative 1, and 0, 7. And our parabola opens to the right. Axis of symmetry is y equals 0. Focus is 0, 3. All right, so let's check out this parabola equation, x squared plus 4x minus 4y. We know that because the squared term is with the x, we pull our x minus h squared equals 4a y minus k. Our parabola equation has our x's on one side and our y's on the other. So you always want to set yourself up so that your x's are on one side and y's on the other. And the one with the squared term will determine what you want to make it look like. So we have to somehow make this one look like this one. What property, what tool are we going to use to make that happen? So we are going to use completing the square. It's a skill we learn in Algebra 1, and we kind of put it in our back pocket and practice it for 3 years until we get to this point and we actually need it to determine conic sections. So we look at our x term, we divide it by 2, so 4 divided by 2 is 2, and then we square it to get 4. So always take your term, your middle term, divide by 2 and square it. So that means we add 4 to each side. That makes this a perfect square, and we can rewrite it as x plus 2 squared. We go ahead and factor out the 4 on the right-hand side, and we get 4 parentheses y plus 1. So now we can clearly see that h is negative 2, k is negative 1, and a is 1. The focus is at negative 2, 0. And the directrix is the line y equals to negative 2. And we can find the focus and the directrix using the equations, the x plus a for our parabola equation. Okay, so that looks like this guy. Our vertex is at negative 2, 1. Our focus is at negative 2, 0. Our directrix is at y equals to negative 2. Our axis of symmetry is x equals to negative 2. And we can see that we don't need to draw it in, but our lattice rectum is at 0, 0, and negative 4, 0. Okay, so application problems. We see a parabola in lighting. We see it in telescopes. We also see it in mirrors. So we have a satellite dish that is shaped like a paraboloid of revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point where the receiver is located. Boop. If the dish is 8 feet across at its opening and 3 feet deep at its center, at what positions should the receiver be placed? This is also known as the focus. That's why it's called the focus, because we focus it at that point and it emanates out. So if we draw a picture of this scenario, let's go ahead and put the vertex at the origin, 0, 0. We know that at 3, we are 8 feet across, so points -4, 3 and 4, 3 are on, because from here to here is 8 all the way across. So this is a pretty accurate representation of our satellite dish. We want to put our focus at 0, A. So since 4, 3 is a point on the graph, we go ahead and pull our x squared equals 4ay equation. X is going to be 4 and y is going to be 3. So we square 4 to get 16, and that equals 3 times 4, which is 12. And we divide both sides by 12, so 16 divided by 12 reduces to 4/3. So A is equal to 4/3. So that's what that guy is. It's 1 1/3. So the receiver should be located 1 foot. 1/3 of 12 inches is 4 inches. So 1 foot 4 inches from the base of the dish along its axis of symmetry.